Yes, last question. Boom. Felt like quite a long paper, 19 questions. There's quite a lot of small mark questions, but yeah. So that's quite a good, yeah. Quite a lot in that. Just to quickly recap, because we're just doing one question in this video. We did some fraction work. So fractions, just laying your smile across. For multiplying, you're multiplying top, multiplying the bottom, and for divide, you're doing KFC, keep, flip, change. Okay. For these, it doesn't get much easier. Just don't forget to do your little table. Okay. Simultaneous equations, you're multiplying both equations by a number to give a number that is the same. Okay, so here times that by 3, times that by 2, and that meant that the x's became the same, they became 12. So I did this equation, take away that equation, which got rid of the x's, okay? Nice and easy. Vectors, the vector question was dead simple. It was just this vector here, take away u, which gave us v. Okay, so usually they're just, if you add vectors, you add, the top line, the middle line, just normal adding. If you're taking away, it's the same. And if you're multiplying, if there was a 2 in front of that, you multiply them by 2 or whatever. Okay. So we did a little bit of vectors. For this question here, we solve. So solve just means find the roots. So the roots are where the equation cuts the x-axis. And we were able to do it with the simple method because it was we didn't need to use our quadratic formula. It's just a nice simple method. Add to give you this number, multiply to give you that number. So what two numbers add to give you that, multiply to give you that. Get your factors. Quickly went over graphs. A is the height of the graph. B is the period. So usually it's 360 is the period for the sine, cos, and tan. But here it was 90, so we knew there was 4 of them, so that became 4. Did the equation of a straight line, y is equal to mx plus c. C is where it cuts the y-axis. M is the gradient. The gradient is y2 minus y1 divided by x2 minus x1. So we got 2 points, dead easy. All right. We did nature of roots, so that's the discriminant, which is part of the quadratic formula, b squared minus 4ac. So we said if that number is 0, there's no real roots. If that number is 1, sorry, that is equal to 0, you got 1 root. Sorry, if it's less than 0, there's no real roots. If it's equal to 0, there's 1 root. And if it's greater than 0, you get 2 roots. Okay, so yeah, that's the discriminant. Okay, so that's actually 2 questions on roots already, actually. The angle chasing was brilliant. So just remembering angles in a triangle, 180, angles around a circle, 360. Opposite angles, they be the same. Z angles, they be the same. F angles, the 180 rule. Everyone forgets the 180 rule. That's really important. It's actually a very easy rule as well. Similar, it's basically half the 360 rule. Right? So yeah, did a bit of angle chasing. We did our cosine rule. Again, if you do a question that's got 3 sides in it, you're definitely doing the cosine rule. Okay. We did denominators, rational denominators, so we instantly multiplied it by itself. We did, if we get any root in the bottom, so say that was root 7, we times it by root 7 over root 7 just to get rid of that. Because in this case, root 6 times root 6 gives us 6, root 7 times root 7 would gives us 7, root 8 times root 8 gives us 8. Okay, so we did this to get rid of the irrational denominator, and then we simplified. So in this case, it was just 9 over 6 became 3 over 2, and the root 6 we couldn't do anything with. Okay. Just remembering root 40 is the same as root 20 times root 2. Okay, so yeah, we kind of went over some of the CAST diagram, or the all smokers take cancer, which I said. That is not a fact, but smoking cigarettes are very good for you. So yeah, 60 degrees was given, cost of 60 is a half. So it meant that we were asking what would the value be for 240? Well, 240 is in this quadrant, so all smokers take cancer. So in this quadrant, tan is positive, T for tan, so the cost will be negative, okay? And in this quadrant, the value is 180 plus theta. So 180 plus 60 is going to give us 240. So we know it's a half, but we know it's a negative a half because we're in the T quadrant, okay, the third quadrant, where only tan is positive, okay? And again, you can see that on the diagram as well. So we went through a wee bit of that as well with the quadrants. Yep, just quickly went through some, that was very simple, just spatial awareness really, it's just looking at coordinates x, y, z. We did change the formula and I was saying, put some numbers in, make up some numbers that make sense, and then you're doing it in the opposite direction. Everyone knows that we would do the root, if that was 25, we'd do root 25 to give us 5. We'd then times it by g and we'd add on h. We wouldn't do, right, what's root 25 plus 2 oh no, square root it. Everyone knows how to work through this equation, but when we're rearranging it, people get confused, okay? So you're doing it in the opposite direction to what you usually do. So you do root x times g minus plus h to give us y. So if we want to rearrange for x, we'll do the h last, okay? Or sorry, the h first, then the g, then the square root, okay? So just put in some numbers and then just work by the way. Indices rules, to about them, it's 4 times 2, not 4 plus 2, okay? Finding roots again, so roots have got quite a lot, so if you're good on your graphs, you've done quite well on this. If you're struggling with graphs, then there's a lot of marks to lose there, it's a big part of the syllabus. So yeah, just finding the roots. Turning point and ship, went through that, it was good. Volume, again, they give you all the volume equations, there's not a lot in that at all, that's a really good question. Volume, look for them, dead easy. Sine and cos, don't forget, the only thing you need to know, sine over cos is tan, sine squared plus cos squared is 1, and then I'll give you this other method to do it as well. Completing the square, break it up, look at the first bit of the equation, and keep the minus 81 to one side, and then we half this number, and then we have to do plus 9 to get, minus 9 to get rid of this plus 9 we've generated. Right, bit of that. And then finally, we're on to roots of the equation can be expressed in the form x is equal to that. Find algebraically the values of d and e. Okay, so again, we hear words like roots, discriminant, and solve, and all these things, and we're talking about factorizing, or we're talking about using the quadratic formula. Okay, so find the roots, we're finding the quadratic formula. If it was a nice normal, obviously it's not because that's what the roots are, it would add to give us this and multiply to give us this. But that's not going to work in this case. Okay, so we need to use our quadratic formula. So minus b plus or minus square root b squared minus 4ac divided by 2a. Okay, here. Okay, it's not very good. Minus 2a. So what's our a, b, and our c? Yep, so just remember, you see the word like root, you're thinking of this equation, alright? So a is equal to 1, b is equal to minus 6, and c is equal to minus 81. Okay, so minus b, so minus 6, that's just 6, plus or minus the square root of, now at this point I'd actually just work that out separately, so I would just work out a discriminant over here. Okay, I would just say b squared minus 4ac, I would just do it on its own because it's good having the discriminant as a separate number. Okay, so minus 6 squared is going to give us 36, so minus 6 times minus 6, 36, minus 4 times 1 times minus 81. So this is going to be quite a big number. Okay, so I've got 4 times minus 81. So I'm just going to do a little upstairs, downstairs. I don't take any chances with mental arithmetic. 4 times 1 is 4. 4 times 8, 8, 16, 24, 32, 324. So it's 36. It's going to be plus 324 because this will come out as a minus. There's a minus there, so that's plus. So that's going to come out as 360. 360, yeah. So root 360 divided by 2a, and a is 1. Divided by 2. Okay, and this is where it gets a little bit tricky. Okay, this is why they've saved this for the very end. So now we need to try and manipulate this into this form. Okay, so keep thinking to yourself, this is the form I want to get in at the end. Okay, so I'll be thinking to myself, I really want to get rid of this 2 somehow. Okay, so I'd like to get a 2 into here. Okay, but I've got a root symbol. So the root of what gives me 2? 4. So I'll be thinking I want to say 6 plus or minus root 4 root something over 2. Okay, now 4 times what gives us 260? 90. Now we should know that because if we think of our quadrants, 4 90s give us 360 degrees, like a circle. Okay, so that should be not too bad. And again, this is where knowing your square numbers comes in handy as well. It might help you at the side to write them now and again, but sure. Okay, so I'll just rub that out and I'll just put 2 in there. Okay, so I've got a 6. That's good. So now I'll just follow this through. 6 divided by 2 gives me 3, plus or minus, and they cancel out root 90. So right away I'm thinking, well, this is starting to look good. Okay, this is kind of the form it's wanting. But it's got d, d, e, so it wants it to be d plus or minus d, then e. So actually I need to have a 3 in there. So again, I've got 90. How can I try and get a 3 in front? Well, root what gives us 3? Root 9. So I say 3 plus or minus root 9, root 10, because 9 times 10 gives us 90. That would become a 3. 3 plus or minus 3 root 10. Okay, done. Now that is because I think it's easy when you see the word roots to think quadratic formula. Okay, but in this case it required a little bit of manipulation towards the end. So if I was to look at marks for that, you would get a mark for substituting incorrectly into your quadratic formula. Okay, you would then get a mark for working out the discriminant. So that's a mark there. Okay, substituting in the rest would be another mark. Solving it would be a mark. Yep, and then the finishing into this form would be another mark. Okay, and I think you should also finish with a sentence here that says, you know, d equals 3 and e equals 10. Okay, you don't have to. This is fine, but it's not a bad idea. So that's what I go to when I see the word roots. Okay, but you've got to remember this is part of question 19. Okay, so if we scroll up, we worked out that it was x minus 3 squared minus 90. So I'll just put some different color pen. X minus 3 squared minus 90. Okay, so that's y is equal to. And we're saying find the roots of, because it said this equation up here, that equation is the same as this equation. Okay, so we're finding the roots. The roots of y is equal to 0. So we just set this equal to 0. Okay, so let's move 90 over. 90 is equal to x minus 3 squared. And the only hard thing here is now we're doing a root on both sides. Now root 90 is almost the correct answer. Okay, the true correct answer is plus or minus root 90, because 30 times 30 gives you 90. Sorry, whatever times whatever gives you 90. But the negative of those two numbers is also going to give you 90. Okay, so the plus or minus is very important here. And then we should move that over. So minus 3 becomes plus 3. So it's going to be 3 plus or minus root 90 is equal to x. And then you're at the same position you were here. Okay, they're the same. Alright, so because you're in question, I've run out of time here. Because you're in question 19, you should be thinking it might have something to do with what we just worked out. Okay, so both methods are totally valid. This method, I would argue, had a little bit less fudging of the roots, I think, but it's still very possible. Okay, still very possible to do. But yeah, that's two methods, food for thought. So thanks for sticking with me through the paper. I really hope that was helpful. If you've got any questions or anything you'd like a video made, I'm happy to help you. It's quite good practice for me just to go through some of these and have a wee think about what's going on. So yeah, thanks for watching. Hope it was good, and yeah, good luck with whatever you're doing. Cheers, thank you, bye.